On March 21st of 2023, thunderstorms were going through the Central Valley of Northern California, and one thunderstorm did do damage to the area around Woodland back around 4:30 in the afternoon. There was damage to trees down, there were power poles down across the road. Now, there had been some sketchy video, if you will, of some funnel clouds that had been spotted in the area, leading some to think that the damage in Woodland was caused by a tornado. What I want to do here is examine that thunderstorm with radar to show you why this was most likely straight line winds, a downdraft, if you will, out ahead of the thunderstorm itself. So with that, let's go ahead and examine that thunderstorm here with radar. I'm going to go back to some archive data, and what you'll see here is this is the time back around 3:30 to 4 in the afternoon. And as you can see here, let me just widen out just a little bit. You'll see we had that low spinning around down off the coast, and then out ahead of it, we were spinning up in the very unstable air, these thunderstorms. Now, I do have the time up here in the upper corner, so you can see the time that we're looking at here. It appears as though the damage appeared maybe around 4:15 to 4:30 in the Woodland area. So let's go ahead and zoom in on Woodland. And you'll see that thunderstorm coming into the area from the south. It had gone through Davis with some heavy rain as well. I'm going to stop it here at the time that we most likely had some of the damage. And again, this is at 4:30 in the afternoon. So this is the line of thunderstorms, and it's moving to the north. And now, they're embedded in here is a fair amount of hail as well as lightning. But to really examine this, you can't just look at the reflectivity. You also want to look at the velocity data. So with that, I'm going to show you the velocity data as well as the reflectivity. All right, so what I've got here, let me just do one at a time. That will be easier on this screen. Let me just show you the velocity data. Okay, so here is the same thunderstorm here as shown by the velocity data. Now, the radar itself is right down here at the bottom of the screen. So with that, when the radar is that close, you get a really good idea of just how strong the winds can be, because the height of the radar beam by the time it gets to Woodland is only 700 feet off the ground. It's 13 miles away from the radar. So you're getting a really good depiction of how strong the winds can be. And also, let me point out one other area down here that I'll examine in a little bit too. This area here is only 400 feet off the surface. And if we examine that in terms of how strong the winds were, you can see the winds here only 400 feet off the ground. This isn't too far from Sac International. We had 50-mile-an-hour winds. And that's, again, just 400 feet off the ground. But if you come up here to the Woodland area, what you're seeing here, the winds were maybe 30 to 40 miles an hour. Let me just see if I can back this up just a little bit. This is the frame that I want to examine most. Right here. 57 miles an hour, 65 miles an hour. And this appears to be about the time that we likely had the wind damage. What you don't see here, and the reason we show you the velocity data here, is when the red colors, that means that the wind is going away from the radar. You'll notice that here, that what we're looking at is the radar, and on the south side of the radar, the wind, the colors are green. That means the wind is coming toward the radar, and on the other side, it's going away from the radar. So as we look at the Woodland area and zoom in on that a little bit more, you notice that the colors are all uniform here. And again, if we examine this right here, these pixels right in here, 65-mile-an-hour winds at just 700 feet off the ground. So you're not really seeing the twisting motion that would be required to get a tornado to go through here. So what we were most likely looking at was straight line winds. So that's what is really helpful here about having velocity data to back up the reflectivity data. And while, again, there may have been some funnel clouds spotted here and there, this is why it is most likely that the damage that we did see in Woodland on the 21st was a result of straight line winds.